G'day Year 9. So we're just going to look through the probability style questions that we did. And just going to start with a reminder here. The probability of event is the number of favourable outcomes, the number of outcomes you're looking for, divided by the total number of outcomes. So we're going to start by rolling a die. It's a singular dice. And we're looking at a number. And so we're looking at what the different probabilities are. So the probability of rolling a 1, so the probability of the event, okay, which in this case is a 1. So what number of favourable is? Well, we're only interested in getting a 1. So there's only one favourable event out of the 6 possible events. So the outcome is going to be 1 out of 6. Let's have a look. They're not going to quite line up, so I'll just draw little arrows where they go. The probability of an odd number. So in this case, it's the probability of a 1, a 3, or a 5. So when you're rolling a dice, there's those 3 numbers you can get out of the possible 6. We always want to simplify. We've got a common factor between the top and the bottom of 3. So the probability is 1 on 2, which we also say is 0.5 is 50%. The last one, okay, the probability of a number less than 7. So the numbers less than 7 will be 1, 2, 3, 4, 5, 6. So on a 6-sided die, we're going to have 6 possible outcomes out of the 6, which is 100% that we're going to get roll those numbers. The next one, we're looking at a Venn diagram. I'll just move this down and give ourselves a little bit more room here. So we've got the sample space, and my class knows I'm terrible at drawing this. So there's 26 students in total. And we've got dogs and cats. Oops, this is not going to work well. Let's see if I can just quickly go back here. Dogs and cats, and a little bit that overlaps. So we've got 4 people. We're asked to put the information on the Venn diagram. We've got 4 people that own both cats and dogs. We've got 12 students that own a dog. We've got 4 that own a dog and a cat, so there's going to be 8 other students there. So in total we'll have 12 students own a dog. Similarly, we've got 4 people own a cat, 7 in total own a cat, so there's going to be 3 other cats in here. So now we've got 8 people that own a dog, 4 that own both, so that's 12, and another 3 that own just a cat. That's 15 out of 26. So there's going to be 11 people out here who don't own either a cat or a dog. So that's our information on the Venn diagram. So what's the probability that a student owns a dog? Probability of a dog. Similar things, similar to what we were talking about before. We're looking at the number of favourable outcomes divided by the total. So we know that 12 students own a dog out of the 26 people in total. When we've got a common factor of at least 2 there, so let's see if we get 6 13th. The probability is 6/13 that a student owns a dog. Students owns a cat or a dog, but not both. So we're kind of asking here, probability of just cat, just dog, not both. Let's have a look at those numbers. Students who own a cat but not a dog is 3, a dog but not a cat is 8, so there's 11 out of 26 as the probability there. Okay, I just need a little bit more room. Finding probability here, we've got a bag of marbles, and we're taking those marbles out of the bag. So we're asked here the probability of drawing a red marble, so probability of red, and then the probability after that of drawing a blue. And importantly, we're saying that the marbles aren't replaced. So there's going to be a different set of marbles after the first one. So let's think about this probability of drawing the red out first. In a bag of 10 marbles, 5 are red. So it's going to be 5 divided by 10. That's the probability of drawing the red. Now, once that red marble's gone, there's still going to be the 5 blue, which we're thinking about the next time. However, there's only going to be 9 marbles left in the bag. So let's multiply these things out. If we multiply 5 by 5, we get 25 divided by 90. And I can see that there's going to be a common factor of at least 5 in here. That's going to be 5 on 8/10. That's the probability of drawing a red marble first and then a blue marble. Now we've got John, Adam and Stephen in a class. And the teacher's going to form a group of 3 students. It's a class of 10. And there are 10 pieces of paper with different names on it. So let's see, we've got John, Adam, we've got Stephen. We've also got, these are messy pieces of paper, 10 pieces of paper with other people's names on as well. What's the probability that John, Adam and Stephen will be the first 3 names for the group? So we're looking for the probability of either one of John, Adam or Stephen, then the probability of the 2 remaining, and then the probability of the 1 that remains. So there are going to be 3 drawn in a row of these students. So let's have a think. The first probability is not too hard to calculate because there's going to be 3 students and 10 pieces of paper. Now, the question says they're not going to put the name back, but of course it doesn't make sense. It does make sense to put the name back because if you put the name in and drew it again, it's not going to affect the group of 3 if you just draw whoever's first. So there's only going to be, the next time that we've got it, there's only going to be 9 students that we're choosing from. And we're interested in whoever got drawn, doesn't matter which order they're drawn in. There are 2 names that want to be in that group out of the remaining 9. And then once you've drawn that second piece of paper, there's going to be 8 pieces of paper left and 1 student that's waiting and hoping to be drawn. So that's going to give us 6 ways out of 720. 720 being 10 by 9, 90, 9 eighths, 72. And if we're looking for common factors, I think that 720 is going to actually go into 6 neatly. I think it's going to go in 1 in 120. But you can use your calculator for that to divide both the top and bottom by 6. And so that the probability of John, Adam and Stephen being the 3 that are drawn is 1/120th. And they're our probability questions.